gas at 40 or a little bit above. Then unpack your spool gun. Now get the right settings for aluminum wire, 4043, 0.35 diameter. Install the spool gun into the Euro connector. Make sure the positive pigtail is locked in correctly. That supplies the spool gun with power. Hook your 2-pin connector for your spool gun motor drive up. Turn the machine on. Put the settings in that you just got from the charge. Press your button to activate the spool gun. 1/4 inch. And right there, 490 inches a minute, 23 volts. Put those settings in the front. There was your wire speed. Now that you touch the voltage knob, the display switches over to voltage. Now let's load a roll of wire and we're good to go. Now as you can see, I have a little bit of an unconventional approach there. I never really open it and run it through the drive roller. I straighten a piece of wire out and then under throttle, pull the trigger, run it right through. So this was the back side here. Of course it was a little bit too hot, as you can tell. Flipping it over, looking at the front side. And yes, that's absolutely more like it. Those are the results you're used to see. You see typical spool gun fashion, the start, the first 3/4 inch a little bit cold, and then all of a sudden it welded like the way it's used to. This is 1/4 inch material, 0.35 wire. So the first time around, I didn't exactly like the way how it was welding. I mean, it was nice, but I wasn't used to everything. That was the first weld I ever did with that spool gun. So now there's another 1/4 inch coupon, 4043 aluminum wire, 035, same settings as last time. And you can hear just how the arc runs, that it's so much smoother, and it just does what it's supposed to do. And this right here is the biggest no-no of all times. You can't just weld the backside and expect a decent result. Now your coupon is preheated, your settings are way too hot. I didn't let it cool down, I didn't lower the settings. So you will see when I show you the pictures on how this actually looks like and why you never really want to do this. Front side looks absolutely immaculate. Backside just destroyed, absolutely concave, peppering in it. You can tell it's way too hot. So now let's do the same thing on 1/8 material thickness. What do we have there? 375, 18.5. So yes, 375, 18.5. You got to pay attention when you read those charts. It's so easy to jump a line there. But anyhow, we're going to set the machine to that. We're going to do the same exercise. We're going to do the same T-joint, weld the front side with the original settings, and then weld the back side with the same original settings and totally annihilate it and see what happens if you don't follow the advice that I'm trying to show you. Aluminum is a very thermic driven process. It's all about the heat input. To see how good or bad a weld is, the front side will only tell you less than half of the story. You flip it over, look at the back side, and it will tell you the whole story. Now when you listen to this and you say, there's still a little bit popping in there, I agree, this could have benefited from another 0.3, maybe 0.5 volts to get the arc just right, but I didn't. I mean, this is the settings by the door chart and it got me really close. And you see that the second run here, the crackling is already less because the material is preheated. So the front side, maybe a smidge too cold. Again, that 0.3, 0.5 volt more, it could have stood that. A little bit less crackling, it would have wetted out a little bit nicer. But typical spool gun fashion, it's a good commercial weld. There's nothing really wrong with it. On the back side, holy moly, look at this. Absolutely concave, black, and it got so hot that it cracked entirely through the parent metal. I mean, there's no saving this at all. That is the risk you run overheating your aluminum. You see the first side on the top at just the right amount of penetration. It wasn't really a weld that was too cold. The second one just totally blew right through it. On that 1/4 there, it could have stood a little bit slower welding speed to push through a little bit more, but overall, not bad.